All right, ready?
Yeah. Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Dan Maloney.
This is episode 323, Impossible CRT Surgery, Fuel Cells, Stream Gauges, and a Love Letter to Microcontrollers. We've got tons of Hackaday news this week. First up, the new law coming out in Washington State, customers gain right to repair for cell phones and more. Yeah, victory for right to repair is a victory for people who like to mess around with things on their own. It's also, of course, a victory for independent repair shops. This law in particular looks like it covers the usual ground in getting tools and documentation and replacement parts and stuff to independent repair shops, but also to people who want to fix their own stuff.
Yeah, I don't know how this affects me. I live only about 20 minutes from the Washington border, so when I buy something, should I buy it in Washington? I don't know.
You could drive over to Washington and try to fix it there. It also mentions things like parts pairing, where manufacturers try to prevent you from using their parts to fix it by making them work with other parts of the system that are out of your control. So operating systems, checking for IDs on replacement parts, et cetera, et cetera. It's looks pretty good.
Yeah, there's always unintended consequences with all of these.
Oh,
so
for sure.
We'll see. But we read the bill, so you don't have to. Actually, we only read part of it, so... So you might have to read the rest of it.
Yeah, and if you're a lawyer, you're definitely going to have to read the rest of it because we are not. Nothing in this chapter shall be construed to require an original manufacturer to make available any parts, tools, or documentation for the purpose of making modifications. So you don't have the right to mod. You just have the right to repair. You can't force them to divulge trade secrets, stuff like that. So, there's going to be shenanigans, but at least they have caught out, I think, some of the main ones. But like you say, we'll see what happens. In sadder news, NASA is shutting down the International Space Station sighting website. This was a website where you could go to, type in your latitude, longitude, and it would tell you when the ISS was passing by overhead. It was a cool thing to do. Their claim is that everybody uses the phone app these days and nobody uses the website. So, in that sense, it's no worse. What's fun about this is that the comment section rose to the challenge and sent in a whole bunch of other websites that can track not just the ISS, but all sorts of other satellites and things you might want to poke your eyes or binoculars or even a telescope at as they pass overhead. So if NASA can't keep their specific site up, the rest of the world is filling in.
On the other hand, if you want a little more intimate information about the space station... I'll be writing up an article on a tracking system that takes into account certain unmentionable fluids aboard the space station and their current status. So watch for that in links on Sunday.
The ISS API covers more detail than you want to know. And last up, the pet hacks in the pet hack contest. We've got a cat facial recognition system to prevent the wrong cat from eating the other cat's special dietary food. A really cool looking water fountain that it looks like the cat is super well adapted to, actually. And a barrel for a Berner Zennerhund, a Berner mountain dog, to wear around his neck, so he looks like the stereotype dog coming to rescue you, in the snow in the high mountains. This one carries dog poop bags, which I guess is eminently more useful. But Jenny does suggest that maybe you could slip like one of those little miniatures of rum in there or something too.
I've been up since 4, since our cat had decided that he didn't like the kibble that was on his plate and he needed fresh kibble. So
oh, no.
I have a quite different view of what pet hacking should be today.
You need an automatic pet feeder.
I know,
if you had an automatic kibble feeder.
I keep meaning to build one, and then he goes on strike and doesn't wake me up, for months on end, and I lose track of it, and then all of a sudden he's jumping on my pillow and trying to wake me up at 4 a.m, so...
Exactly.
Cats are jerks, what can I say?
So as you're listening to this, the contest has come to an end. We will be sending these out to our judges, getting them judged. And by the way, thanks to DigiKey, winners get a $150 DigiKey gift certificate.
This is a journey into sound.
What's that sound?
What's that sound?
Which brings us to What's That Sound? This is a contest where we play a mystery sound. Dan tries to guess at it. If he succeeds or fails, you get your chance to guess at it. We'll send a randomly selected correct answer, a Hackaday podcast t-shirt. You want to give it a try?
All right, let's see. Oh. Oh, that's a deeply unpleasant sound.
Is it? If it's playing twice, I played it one time slightly slower than the first time to keep more of it in the range of human hearing.
Yeah, it sounds like gas entering or exiting a tank of some sort, like maybe liquid oxygen or liquid hydrogen or something like that coming out of a tank, but I don't think so.
Why is that?
I don't know. It just doesn't.
Well, that it is not. So maybe our listeners will have a better chance at it. I'll tell you what it is in just a second. So if you have a guess as to what the sound is, head on over to hackaday.com/podcast. Find this episode's write-up. Scroll on down to What's That Sound? Click there, fill in the form, give us your handle and your best guess, and we'll see who gets it right next week. All right, well, let's start up the hacks. I picked a video this week, A Love Letter to Embedded Systems by V. Hunter Adams. Hunter is the professor at Cornell who is doing the embedded/microcontroller programming class for their engineering school there. And he's taken over from Bruce Land, whose name you might recognize because he's been submitting his students' awesome projects to Hackaday for probably as long as I've been reading Hackaday, maybe as long as Hackaday has existed. So thanks, Bruce, wherever you are. And thanks, Hunter, for carrying on the tradition. This is a recording of a lecture he gave kind of midway through the class. And the class is a practical class. Teach them everything about microcontrollers, and the students have to make a final project. And they often end up being really interesting. This lecture is kind of more philosophical. It's why Hunter likes this stuff, why he likes engineering, and why he likes embedded engineering in particular, and why he likes microcontroller projects. And I thought it was just a great talk. And in fact, if you go through and everywhere he says engineer, you substitute hacker, it basically is the hacker ethos from beginning to end. I just found myself nodding along the whole way. So give it a watch if you're thinking more philosophically about what it is that we all do. You know, why we build stuff and why it is that the stuff we build, especially hacker projects, but apparently also embedded engineering projects in general, require more breadth and thinking out of the box than, comparable projects. If you're doing architectural engineering, you're probably going to be working on buildings the whole time. But if you're doing embedded, you might work on an oceanography project one time and a space project the next time, and then a consumer goods project. And one thing he says here is that kind of values a broadness of interest that he doesn't feel is true of kind of other disciplines in engineering. And he brought up Leonardo da Vinci and told the parable of the Mona Lisa, where people might have said Leonardo should have spent more time painting and less time screwing around with other gadgets and doing his other engineering side projects, some of which work, some of which are total flops. But then if he hadn't spent, for instance, all his time in the morgues learning about human anatomy, would he have been able to paint the smile on the Mona Lisa? And so there's this kind of breadth versus depth of interest. Hunter sides with Leonardo. Hunter says that doing microcontroller projects, you have to involve this kind of broader hacker perspective. He says engineer. Perspective to do these kind of projects. The other thing he said that I really loved was that projects are filter removers. You may not see the way this particular class of things work until you really get in and dig in and figure out how it works at the lowest level and kind of implement it yourself. Because you take this for granted, right? You're just like, well, this is the way Bluetooth works, until you have to implement some Bluetooth devices yourself. And then you really learn how it works. And that, opens your eyes to a world that you may not have seen before. And there's nothing that does that like being confronted with the hard reality of making something work. Last, of course, with these kind of small projects, and here he said, small, low-risk engineering projects. But again, that's hacks. These are projects where it's small enough, the sandbox is small enough that you can become master of it. But a microcontroller with a 500-page data sheet, there's also enough in there that you can dig in deep. And while it's possible to master it, there's enough to keep you interested. A lot of these projects tend to be constrained and, safe for you to make mistakes and explore around, at least in, the early prototypes, which I think is super important for people figuring stuff out on their own, but also engineers young in their career or students in an engineering class. Of course, then there's interacting with the physical world, and you end up doing something that has presence in the physical world, whether it's a Bluetooth keyboard or a robot or whatever. So I think that's really cool. It's just a really great love letter to embedded systems. And although it's aimed at an engineering class, like I said, you can control R, search and replace engineer with hacker out of most of this. And it's basically why I love hacker projects.
Yeah, a couple thoughts on this. Number one is, as far as embedded systems go, I don't know, I remember getting like a complimentary copy of Dr. Dobbs' journal many, many years ago, probably in the 90s. I remember seeing a column that kept coming up on embedded programming. At that time in my computer development, I really hadn't thought about the constraints of having to, design a sound system for a like some cheap toy or something like that. And it seems like it's such a trivial thing to design because you're going to put it in a toy that someone's going to throw away, or you're going to put it in a McDonald's Happy Meal or something like that. But being able to do that at volume, meeting a price point, and the trade-offs that had to happen to make that work, that was made clear to me by this one particular article that I read. And I've always been fascinated by that design trade-off, cost versus performance and all that stuff in mass-produced electronics ever since. And I never thought about it before then. And that's when you talk about embedded systems, that's the first thing I think of is that kind of aha moment that I had. The other thing that strikes me about this is that V. Hunter Adams really seems to be the kind of teacher you want to have standing at the front of a classroom. There was apparently some comments in the, to the video about how he was like Sagan-esque in his ability to communicate details and communicate a passion for embedded programming. And that's someone you want up in front of a classroom. And, speaking from experience of having had some pretty bad teachers and some pretty good teachers, and my wife's current experience with where she works, the college she works, there's a lot of people in the division who are just sort of phony at home. That's kind of sad to me that you've got, this subject matter that I feel like would be super interesting and I would love to teach, but you've got somebody standing up in front of there just sort of droning on and wasting this opportunity to maybe open up a few channels in these kids' minds. Those are the two things that kind of strike me about this, that he's got a lot to be passionate about, and, he's actually putting it into action in class, and that's pretty cool.
I've been following this class from afar on Hackaday for I don't know how long. And Bruce Land was also one of those teachers. He was also one of those teachers
definitely.
Who could really, he just had the passion for it. And so I'm super stoked to see someone else who has the passion for it take it up. I mean, again, even if this only reaches the Cornell students, the nice thing about it is they do also throw these lectures up on YouTube. So have at it. And the other part of the requirement for the students is that they fully document and put their finished projects up on the web. So it's like, they could have their own little mini chapter of Hackaday over there. So go check their projects out. I'll have to find a link to the ECE class for you here. So you can go check out the student projects because there's a lot to learn from them too. It's really cool.
The open question here is, can he rock a Hawaiian shirt like Bruce did? Because
I don't think anyone can rock a Hawaiian shirt in class like Bruce did. If you aren't into embedded systems and other computer systems, rock your boat, and you want to learn how to make an operating system from scratch, just coincidentally, we ran another article about a Cornell computer science class, RISC-V operating system instruction manual. This covers the Earth and Grass operating system, which is named for the kind of lowest hardware level. That's the Earth, and then the Grass, which is the kind of abstracted layer above that. Anyway, it's a super sweet little operating system, 2,000 lines of code. you can understand it, and it comes with some really nice documentation and a video. So check that article out if you're thinking systems, and more codey computer science stuff.
All right, first up for me is reconditioning a vintage CRT tube. This one brings me back quite a ways. In the 1980s, I worked in a TV repair shop, and CRTs were the only show in town. That was the only way to look at a picture. The CRT was always kind of this holy of holies, mysterious center of attraction of the TV chassis. You take the back off, and the yoke and the neck of the tube were sticking right out at you, and the yoke is surrounds the neck of the tube and has this complicated sort of look to it, and you can kind of get a look inside the neck and see the electron guns in there, and I knew the theory of how they worked, but I'd never really gotten up close and looked at the innards of a CRT, and there's some pretty cool stuff in there that you sort of look at through the glass. Well, you wanted to repair something inside the tube, and that was clearly out of the question. You would just replace the entire tube. If anything went wrong with the electron gun, the tube was toast. You'd go order a new tube, and the customer would cry because it was very expensive, and you would replace the tube in toto. But not so with ColorVac, who has a full setup, a full shop to do internal repairs on CRTs. And this video shows them in action doing this very sketchy looking procedure where they start by cutting the neck of the tube off with the circular glass cutter sort of thing, and scoring the neck of the tube, and then somehow fracturing off the section that actually contains the electron guns. The whole idea of actually doing an in-tube replacement of electron guns is fascinating to me. I'd never seen it done before. I didn't even know you could get electron gun assemblies. I don't know where they're getting them. Are they harvesting them out of tubes that are damaged in some other way? The phosphors are worn out, or the shadow mask is bent, or something like that. I don't know. They don't go into that detail. They may in other videos in their series, because apparently they have quite a few videos on this repair. But basically what they're doing here is cut the neck off, put a new neck on. They've got a special rig for welding the glass tube to the remaining stub on the CRT with the, probably oxypropane flames. And then they put a new set of guns in, a whole gun assembly in, and seal the neck and pump it off and seal up the tube. It's kind of the 1970s, 50s, 60s, whatever version of die level repairs on a chip. Very few people would dare to take the epoxy off of a chip and repair a bonding wire or do some sort of repair at the lead frame, die level or something like that. And this is kind of that to me, is this level of precision that you need. In addition to the fact that the repair is mechanically complex, at the end of it, you've got an electron gun assembly that may be slightly out of line with where it needs to be, sort of radially in the neck of the tube, and you've got to deal with that, put the tube back together, put the yoke on, and adjust the convergence, and hopefully you're within the range of adjustment of the convergence controls, which are pretty limited as if memory serves. Yeah, but just that kind of a field that I never even knew existed. Being able to do internal repairs like that is just wild to me.
Yeah, tubes at all are kind of mysterious to me. Yeah. I guess intellectually I understand that it's just a glass vessel full of vacuum. Yeah, crazy. Everybody in the comments is like, yeah, you wouldn't do this for many tubes, and it'd have to be a special TV. And of course, this is all true. But I can see a future where the last TV tube has been manufactured, and the only people with CRTs are the people who know these crazy cyberpunk dystopian back alley factories where they can rejigger CRT tubes. Walking into the shop with the last Trinitron on Earth. Can you make it go again?
Trinitron's another thing altogether. The inline guns are... anyways, getting into the weeds down there.
See?
It was very cool to see the electron gun sort of exposed like that. The only ones that I ever was able to hold in my hands and inspect them up close rather than through glass were ones from defunct tubes that I had mistakenly imploded and then harvested the guns out of just to get an up-close look at it. I do remember, too, that the process of degassing those tubes, or regassing them, I guess, it was terribly stinky. I remember a particular kind of a rotten eggish almost odor that would come out of the tubes Maybe it was the phosphors. Maybe it was the aqueduct on the tube surface. I don't know what it was, but it had a very distinctive, almost, it was more like oniony kind of smell. It was very unpleasant. So it smelled like something you weren't supposed to be breathing. So I made sure I wasn't too close to it. But yeah, I just remember that in general. I wonder if, I mean, we call them vacuum tubes, but they generally are, there's still gas in them. I wonder if there's some sort of sulfide gas or something like that that's in there for whatever reason.
Make them stink so the kids stop opening them up.
Yes.
Darn kids.
Just like the canned air, right? Contains an embitterant, so you can't abuse it. And I'm like, ooh, well, challenge accepted.
If you think CRTs are old tech, how about the luminophone? This is a really cool, possibly the first electronic musical instrument. It had a disc with a bunch of holes in it. You'd shine a light through that would hit a selenium photocell and then go through transformer and, of course, a vacuum tube amplifier and play it. The rate at which the holes pass through the photodetector-photoreceiver pair, of course, determines the pitch that this thing puts out. And it's strangely like the first sirens, which were basically a disc with a bunch of holes drilled in it, and you'd blow through them. And so the puff, puff, puff of air fast enough, if you cranked it fast enough, would make individual pitched tone. And this was actually how physicists discovered what made sound in air anyway. This is kind of the light and electricity version of that. The disc spins at 400 RPM, and how frequently the little holes pass by. It's actually also a lot like the way the Hammond organ worked. And in fact, there are tons of musical instruments that work on kind of this siren principle. And actually, I wrote a piece up, one of the first pieces I wrote for Hackaday, first long pieces, way back in the day. You go check it out, Drawn In by the Sirens song, where I go through both the kind of siren-y things that were used for science, but then a whole bunch of them used for making music. In that, I actually have a thing that I made, which was a copy of a project by Gages, who's kind of a Dutch electro-punk hacker dude, who made a really neat device out of an LED and a fan and a light-dependent resistor. So it's kind of exactly the luminophone. And I spun off on that idea, which I've always loved. So actually, I have a video of it. It still sounds really cool to this day. But this sort of idea is really fun to play around with, and it's as old as time. I think if you haven't played around with spinning things that make music, you absolutely should.
This project was neat too because I mean you have to go ahead a ways to the end to get the sort of the sound of the finished product, and it's a nice tone that Nick came up with here. It's not done with the same sort of rotating discs and all that. It's more of a synthesized sound, I feel. But it's pretty cool, to hear it again, although, as Brian points out in the article, we don't really know what the luminophone sounded like because there's no recordings of it, which is too bad. But you can see how it would have sound, and it's kind of interesting that the disc, at least in the diagram that's shown in the featured image here on the article, the disc almost looks like a symbol. It's kind of got the shape and the profile of a symbol, which makes sense. If you were going to scan the photoreceptor across the radius, you'd kind of naturally come up with something that was disc shaped like that. But it just sort of strikes me as interesting that you could maybe also get music from the actual chopper disc if you hit it like with a drumstick or something like that.
Yeah, and I do have to say, I kind of side with some of the people in the comments who say, like you said, we can't tell what it used to actually sound like because nobody did this with a selenium cell. And if you really care about reproducing the sound of this particular old implementation of a light tone wheel organ, you probably want to use, vacuum tubes and a selenium cell and transformer and, all this kind of old schooly stuff, if that was really your goal. And, Nick's just turning a laser on and off and hitting an LDR with it. So, is that the same? I'd kind of claim it's not. I really like having the physical thing in the way, blocking the light and letting it through. It probably doesn't matter at all for the sound quality. And, so I kind of do believe this is what a Lumaphone probably sounded like claim. But, something about me likes the performative physicalness of having an actual disc with actual holes in there and that converting into the sound. But I was super stoked to learn about this ancient musical instrument proto synthesizer organy thing that I'd never heard of. So for that, thanks tons.
Okay, next up for me, making a backyard observatory complete with retractable roof. This is the kind of project that is like the holy grail project of amateur astronomers. This one is made by Arrow, and Arrow has a nice collection of telescopes. He's obviously very serious about observations. And just setting up in the backyard is usually enough for the casual astronomy hobbyist. But, you know, if you're going to go, you might as well go big. And Arrow certainly did go big here with this project. The video accompanying the article is kind of just a slideshow of the construction process. This is a backyard. It's like a typical suburban backyard, and builds what looks at first glance to be a cabana, sort of outdoor assembly area, someplace you're going to hang out and, you know, barbecue or something like that. But at the completion, it's exactly what the title says it is, that it has a retractable roof. It looks like the construction is all kind of timber frame, post and frame sort of construction, very sturdy superstructure to hold up the roof and hold up the slide mechanism that the roof is capable of retracting. Like all good observatories, this starts at the ground level with really, really solid foundation for both the building itself, but also for the mounts for the telescopes that are set in massive concrete blocks that are set way into the ground. About 3/4 of the way through the process, Arrow decides that one telescope's not enough, so he rips up the slab and pours footing for a second telescope, so he can have two of these beautiful scopes in his observatory. The roof mechanism is really, I mean, that's where the action is with the superstructure. Looks when the roof is retracted or is in place over the telescopes, it looks just like a shed or something like that, a garden shed. But at the press of a button, a gear motor engages with a chain drive, pulls the roof back on a pair of rails that's basically just made from some angle iron set point up, and with the little wheels that ride on the rails, and pulls the roof back onto a long extension that is outside of the building itself. So the roof fully retracts, and it's got, limit switches and things like that, so it knows when to stop and doesn't just keep going off the end of the rails. I'm hoping that there's some sort of retention mechanism for the roof. I could see a windy day. I don't know where Arrow is located, if it's a place where tornadoes are likely to hit, but I mean, even a thunderstorm with a good, or just a fresh spring breeze could lift up the roof and cause disaster. So I'm hoping there's some sort of locking mechanism. It kind of looks like there's some brackets that look like they might engage other brackets when the roof is fully in place.
The thing that was really neat about watching this process is it's pretty clear that the putting up a roof and building a building is actually kind of the easy part. It's like, here is the telescope, and setting the telescope up and making the base so solid, that it won't vibrate and ruin your observations. And all of that stuff is kind of the main work. At the end, you also put a building that has a retractable roof over the top. But if you are thinking about an observatory as being a building, like, that's just the thing that covers the observatory up, right? And I thought this video actually pointed that out really nicely in terms of just how much effort goes into the setting up of the telescopes part, as of course the exact opposite of my experience with small scopes. But he probably gets a lot better results. And my last hack is a project we've all probably started on at one point in our lives, or at least we have alternative solutions for it. So it's really interesting to see another one. This is I guess it's a crowd supply project by Kailesh Saidsaran, Stamp modular breakout boards for SMD prototyping. And these are the kind of things that you've probably made yourself from time to time if you've had to work with SMT parts and you wanted to breadboard them, or if you've seen the Smart board line of little breakout boards, or even if you've had an extra square inch on a PCB order, you've probably thrown one of these on there. They're a great, the kind of jelly bean thing to have around, because sometimes you just want to hack stuff out on a breadboard, a plug-in breadboard, but you've got SMT parts. How do you make them work together? This one takes a really neat tack on it. The kind of usual breakout and fan out on the front, but then on the back, it has more SMT pads that connect each of the pins of the device on the front either to ground or VCC, depending on where you solder the parts. And so that makes hooking up kind of all the other dumb support stuff you need for a breakout board, like, a resistor to ground to pull down an enable line, or a capacitor to VCC for power filtering, or if it's an op-amp circuit, you've always got these like input filters, or you need a voltage divider on the front end of an ADC, or. And it's always trivial support circuitry that you need. And it's always something goes to ground or something goes to VCC connected to pin 7, right? And so this has that built into it. And I really like that a lot. It also breaks all these out into kind of a castellated ring around the outside, which is why it's called a stamp, because it kind of looks like a stamp. Although whether the Parallax Basic Stamp folks are going to get him for trademark on this, I do not know, but it looks like a stamp. You supposedly are able to connect multiples together, and there's a demo of that, but I think it's got to be kind of cherry-picked. I don't see how you can foresee all of the different interconnections. Imagine you have 2 of these little things, and you want to hook them together, and you want to hook pin 3 on one up to pin 7 on the other, through this resistive divider that you've hooked up on the back of one of the boards. I just don't know how you can make a system modular enough so that you're able to accommodate all of these possibilities. And I don't know that the system does. But I really liked a lot of the parts of its design. And so, definitely go have a look at it. It looks like a fun prototyping system. When you want to make your own little prototyping system, you'll probably want to steal some tricks from this one.
I have to admit, when I first saw this one, I saw stamp. I thought basic stamp. It's like, well, where is it? Oh, no, I see. And it does. It looks like a postage stamp, or at least what postage stamps used to look like when you weren't peeling them off a roll and sticking them on an envelope. It's got a distinctive appearance for sure. I wonder with the chaining them together, I wonder if you could, physically program each stamp with 0 ohm resistors to jump this pin to a source pin to a destination pin, and sort of physically program where pins go or map them, to new locations. Maybe that's a way that you would be able to get around that, apparent conflict. But yeah, still, it's a clever system. You can probably do this exact same thing with a scrap of perf board with that already comes with plated holes and all that stuff, and you could do this yourself. But if you had these sort of in your toolkit ready to go, then probably a handy tool.
And like folks say in the comments, this is one of these situations that we always find ourselves in, and so we all have our own solutions to. And I've seen people, make up little island boards with a bunch of little SMT islands on them, kind of like the old school radio construction mechanisms where they do Manhattan or island cutter
style,
type stuff. But, you can make a similar board like that for SMT parts. There was a system where they had, like, all of the front was connected in rows and all of the back was connected in columns. And so you could wick solder through a hole, like making a via from the front side to the back side, and you could do routing that way. That was a cool design. Like, this is one where just people always come up with a bunch of crazy ideas to try to make a more general purpose prototyping module board. And so I think that's a fantastic use of, this idea. And it's so easy these days to get PCBs made. Like, nothing stops you from dreaming up your own wacky design and getting a million of them made. I mean, it's going to be cheap. But then that brings me to what I think is the kind of undoing of these modular boards, is that modularity's kind of lost its appeal these days when you can just get printed circuit boards made so easily that do the specific thing you want. Like, the cost of getting the purpose built has gone so low in comparison. I don't know if it's worth getting the general purpose thing anymore, except you probably have a stack of the general purpose things on hand. And so right when you need it, you just grab it, set it together. And for that, I absolutely have the fullest understanding. I actually tend to just, take a mat knife to a piece of copper and just cut away the places where I don't need them. And I make breakout boards that way all the time, plus a little bit of light home etching. And the fast turnaround there is super awesome too. So, on the one hand, I definitely appreciate this kind of inventive modular breakout board idea, but I also understand that it's kind of limited. And these days with PCB manufacture being so easy, A, you can make your own modular ones, and B, you could get the right thing made the first time. I don't know. It's just so many ways to get stuff done. You can pick and choose among them and sample from this one and sample from that one. I don't think there's any reason you have to commit yourself to only prototyping in this system or that way. Love to see new options, always inspiring to think up your own stuff.
Yeah, I can see the use case of, instead of building up the demo circuit and, just getting a PCB made for that, you want to mess around with different values of different resistors or capacitors or something like that. So
sure,
this I can see as being easier than getting it made with the suggested value and then, it needs to be a little more, a little less capacitance. Let's, desolder that and then put a new one in. I could see that being a pain. So being able to do that by breaking that out and doing the swap outs, with leaded capacitors on a breadboard, I could see that being useful. Although is a full-size leaded, ceramic disc capacitor that's however many microfarads, is that going to perform the same as a MLCC once you get it in the circuit? Yeah. I see pros and cons both ways, but it's nice to have this as an option. All right, an interesting one. EMF forming was a neat aerospace breakthrough. This is a video that was produced by Grumman Corporation, so the defense contractor, maker of F-14s and many other fine military aircraft. Came via Greg Benoit, who notes that his father was actually one of the inventors of this method of metal forming that I had never heard of, but as soon as I saw it, I was like, oh, I know exactly what that is. This was used to form joints between metal tubes and end fixtures to form torque tubes, which are in the aircraft trade, actually I guess pretty much any mechanical trade, are things like drive shafts and connecting rods, things like that, something that actually transmits torque from one end of an assembly to another. And where they're used on, for example, the F-14 that this video seems to be concentrating mostly on, is like for the actuators that control the leading edge flaps, powered by a electric or hydraulic motor, and has to transmit torque across the whole width of the wing so that all the flaps come down at the same time. And apparently this was a difficult part to form using traditional methods of crimping or welding, or what Grumman came up with was essentially the equivalent of any of those experiments where you've seen someone do aluminum can crushing. So you take a soda can and you put it inside of a coil, like a copper coil, dump a bazillion joules of energy into it from a capacitor bank. The electromagnetic field that's created by the coil very quickly creates an opposing force due to the eddy currents that are induced in the aluminum, and the force becomes this incredibly fast physical force that crushes the can, and crushes it very precisely across the whole circumference of the can, so that you get this necking. I've seen the same thing done to like shrink a quarter down from its quarter size to dime size or something like that. This is essentially the same kind of process, with the addition of specialized machining for grooves in the cap that's going to go in the end of the tube, which is going to sort of form the key to this whole thing. Is these grooves have to be machined precisely in terms of their depth and the angle of the sidewalls and the overall height of these and the number of grooves that are machined into this end cap. And then the whole thing is put into a coil assembly, dump a whole bunch of electrons into the coil, and the tube is squeezed down tight onto those grooves and forms a joint that's never going to come apart. It was sacrificial in the sense that the coil only lasted for one shot, but the coil was literally just a coil of copper wire, so it's not that big a deal. Very cool method that I had never heard of before. I don't know that it has too many applications for, the home gamer, but it's still, something to keep in mind. There's another way to form metal that doesn't require any physical contact with the metal at all, which may have some benefits.
You mentioned the coils sacrificial. A friend of mine used to have a physics picnic where all sorts of dangerous physics experiments were undertaken, among others, coin shrinking and can crushing. And they show it briefly and schematically in this movie. They, have arrows showing you that the coil has the reverse force put on it and it explodes. But you really have to be in close proximity to a big old, 2-3 millimeter thick coil of copper wire exploding to really appreciate how dramatic that is. They kind of undersell it in this video. It's really hella terrifying. When we did it, Tommy insisted that we had cinder blocks all around this thing, and still we had pieces of copper embedded in some of the nearby trees that we were all hiding behind. And I don't see the cinder blocks. I don't see the pine trees. I don't see any of that in this Grumman procedure here, and I'm a little bit concerned that they are not taking safety as their number one priority, because we were hiding from that stuff, because flying sharp shards of formerly wire, man. And to say wire, I mean, this stuff is...
yeah, it's a rod.
I mean, it's a thick wire. Yeah. Well, my first quick hack comes from basically homeless. Invisible PC doubles as a heated seat. I don't know that you want to be sitting on a butt warmer all day, but if you did, you could use the waste heat from your PC by mounting it up underneath your chair and keep yourself toasty. Next up, Tool turns SVGs into multicolor 3D prints. I think 2025 is going to be the year of multicolor 3D printing. This is making super thin prints in a bunch of different colors to serve as signage. This project by Erkant is a simple procedure to get them out of graphical formats like SVG that you would draw with Inkscape and into a kind of very flat 3D model for printing out signs. Strange to be using a 3D printer to make essentially 2D objects, but how else are you going to make plastic on the cheap these days? And last up, Solo Pilot from burnt to brilliant, a toaster makeover. This is the ultimate internet toaster, the mother of all toasters. It's a fantastic project. We often laugh at the internet toaster, but if you make it yourself, you are A, not dependent on the cloud, and B, can experiment with all of the parameters you want. And so he has modes that include toast, bake, air bake, warm, air dry, grill, broil, air fry, preheat, ramp, pause, fans high, fans low. He can set up toaster profiles, etc., etc. The comments go wild with this one, including, I think, my favorite from Strawberry Mortally and then a whole bunch of numbers, which is what this really needs is a toast by color dial. And so you could imagine, instead of having temperature sensors in there, you could imagine having a camera, somehow heat resistant camera, that would tell what color your toast is and get it exactly the right brownness every time. That would be worth putting a Raspberry Pi in a toaster.
AI toast, that's what we need.
Regular old intelligence is sufficient for this one, but is it just me, or does your toaster always toast the second slice harder than it toasts the first?
There is some slice to slice or slot to slot variability, yes. I have a favorite slot that I use.
See, that's crap. This could be
for
handled.
Consistency.
This could be handled by the mother of all toasters.
Okay, my first quick pick is POV on the Flipper Zero. That's persistence of vision, in case you didn't know. And this one is by Derek, who took the extremely useful, but never really used for trivial purposes such as this, Flipper Zero, to build a separate board that goes on the GPIO header and contains a whole bunch of LEDs, and you basically swipe it back and forth. You're the motion that the Flipper Zero receives, and then figures out how to light up the LEDs so that you can get letters or graphics or whatever you want suspended in midair. It's a pretty neat use of something that is usually turned to hacking purposes, like popping open garage doors and analyzing lock signals on car locks. Next up, Commodore 64 gets an HDMI upgrade. This one is by Side Projects Lab, who open up the venerable computer, the best-selling computer of all time, take out the RF modulator, which is pretty useless these days, let's face it, and replaces it with an HDMI adapter. I mean, the problem is obvious here. There's not a lot of monitors left for the CRT monitors or monitors that take analog input left, and it's harder still to find a TV, an analog TV, like the old black and white 12-inch portable that I used as my first monitor for my Commodore 64. This lets you take any HDMI monitor and just plug it in, with the advantage of the sound output being piped over the HDMI connection to the monitor speakers, which is a nice touch too. And finally, look to the sky with this simple plane tracker. This one comes to us from Bank Angle, who uses a simple pan, tilt, zoom security camera to keep an eye on planes flying overhead in the neighborhood. The data for directing the camera comes from an ADS-B receiver, which talks directly to the controls, the stepper motors that control the camera, and you can track flight information in real time. It doesn't appear that Bank Angle has a very good view of the sky, sort of a limited angle of view. But if you had a nice open spot, you could see this thing being useful for getting a shot of all the aircraft in your area.
Plane spotting.
Yeah.
Well, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. This week, I wanted to pick the marvelous Dan Maloney's remotely interesting Stream Gages. And Dan's been doing a series on remote sensing and kind of distributed sensing and sensors that kind of form the unseen layer of science infrastructure all around us. In this case, he's taking on stream gauges, which are used by the U.S. Geological Survey to figure out the water height in rivers and streams. And they use this for both kind of drought analysis and flood analysis. So, water's too high, water's too low. As Dan points out in the article, it's a kind of a proxy for how much water is flowing down the river. I guess that's what they'd really like to measure. But of course, that's kind of correlated with how high it is as well. And the height's easier to measure. What I think's fun about this is that this is a sensor that's put out in the wild. It has to be basically bulletproof. It has to be weatherproof. It has to run without human intervention for a fair amount of time, but at the same time remaining accurate. And it's a difficult engineering challenge to make these things work. The first sensor Dan mentions here sits inside a stilling well, which is something I didn't even think of. You don't want to just measure the flow of water down the river. You want to measure kind of a normalized river height, right? It can't be higher or lower because of waves going down. So you have a special well that creates a nice still environment. It's got some pipes that flow in to make sure that the water level equilibrates with the river, and you have the water gauge inside that. And the first one Dan mentions is also a float type gauge, but if sand and junk and stuff gets into your stilling well, that's not so good. And so the second one that you mentioned, I really love this one. I hadn't even thought about this as a way to measure water level, and I'd thought of them all. This one is a bubble gauge, and so you put a pipe down into the water, and the amount of force you have to push down to get it to bubble out tells you how deep the water is. And so they have either an air pump or a tank of compressed air, and they pump that out through the water to figure out how deep it is. I think that's really cool. And then there were all sorts of temporary water gauges where you kind of use sonar or radar and you run it across the river. He's got this crazy example. I don't even know what these guys are doing. Going over this river on a little cable thing, measuring how high the water is. And then you closed, and this is the part I thought was a really cool tidbit of information, and this is the one that's incitement to me. You mentioned that all of these things feed their data back every 15 minutes or so to the geostationary environmental satellites system, and you just casually mentioned that you can probably listen to these things with an SDR. And I think that's a fantastic idea. I think if I lived anywhere near one of these river gauges, I would absolutely be listening to it to see how high the water was.
I've seen remote installations with antennas pointing up to the southern sky for years. There was a a dam near the house that I used to live in Connecticut. That in the center of the dam, it was a flood control dam. It wasn't a usual, it wasn't fully filled all the time. It only filled up when there were, we had a big rainstorm or a hurricane came through or something like that. But it had an antenna pointing at the sky, and I always wondered, well, what's it doing? Is it receiving or is it sending? Is it, is someone controlling something? Well, it turns out there was a stilling well to measure the height of the water, behind the dam, the impoundment of the dam. And it talked to a satellite. So I've seen those antennas all over the place for many years. But really the thing that got me about this is that it was only shockingly recently that remote reading of the status of stream gauges and dam levels and things like that was enabled. Through the 1990s, USGS hydrologists or hydrographers, as they call them, would do site visits and take the charts off of chart recorders and bring them back to the office and digitize them. So you didn't have this real-time, access to this real-time information. One almost wonders what the point is with floods happen quickly, like that stream gauge that I mentioned at the top of the article that was, a few miles from my house. The river that was on was often, just a stream, but get a rainstorm someplace in the area, even a summer thunderstorm, and all of a sudden the level of that river would go up huge. It would be 3 feet deep or more within a few hours, and then it would crest and go back to its normal level. I don't understand what I guess looking at the data after the fact was better than nothing for the USGS, but even better to be able to look at the data real time, have it serve as a warning. Oh, look, we got a problem coming up on this river here. There's a crest coming down the river. People downstream ought to prepare.
And you don't want to have to send that guy out in the high water to go fetch the paper chart from the thing, right? That's not going to work out.
Well, the gauge house is underwater, but...
Well, that tells you something. That's one data point.
Yeah, so the amount of effort they put into connecting all of these stream gauges absolutely makes sense. I just had no idea it was this, recent that they actually, made that effort. I seem to have seen those satellite antennas all my life, but now looking back on it, that one that was sitting near my childhood home in the 1970s absolutely did not have an antenna on it. So...
right, yeah.
Now it does, and I'm glad that we have access to that data. I've used that data myself. I mean, that dam that was near my house, I used to be able to go onto a website and see how high the water was behind that dam, because that flowed up almost onto our property. At the spillway level, it would have been very close to our property, and we would have had lakeside property. But it never got quite that high. There was other stuff, too, that they had, that they used to use, perhaps still do, to measure the crest of a stream during a flood. A flood comes along and eventually you get to the water's high point, and that's called the crest. To measure that in different areas, they'd use a tube. Tube had a measuring stick in it. At the bottom of the tube was a little container filled with bits of cork. Someone came in and put in a little bit of cork, and then as the river rose, the cork would float. It would float up to a certain point and stick to the gauge. As the water came back, then
awesome.
the cork was still there. So someone would take the stick out and say, oh yeah, 14 feet 2 inches. That was the crest. Stupid simple. But, effective. If it's stupid and it works, it's not stupid, right?
At Hackaday, we see all the crazy ways people measure water levels, right? Like, I guess we see the ultrasonic ping one a lot, but then there's, capacitive ways and all sorts of crazy stuff. Nothing beats just like the float on a pulley that turns the wheel that tells you how high up or how low it is.
Yeah, I mean, it's still labor intensive from the point of view that somebody's got to go out frequently and clean out the silt and make sure everything's good. And, raccoons haven't taken up residence in the stilling well. There must be many surprises. I tried to find someone to talk to about this, and I couldn't really come up with anybody like I did for the Snowtell piece, where I actually got to talk to a hydrologist. This would have been interesting, too, because I'm sure there's stories, like, oh, wow, we found a body stuffed in one of these stilling wells.
Right.
There's probably plenty of stories like that. Even if it's just, I got attacked by yellow jackets because they took up residence in the stilling well roof. One of the things that I didn't appreciate was how much people power is involved in keeping these things working and keeping this network humming. Okay, my can't miss article this week is from Al Williams, A Brief History of Fuel Cells. The idea of fuel cells came to me probably the first time with the space program and learning that most of all of the Apollo program and most of Gemini was powered by fuel cells, and I had no idea what those were at the time. Come to find out that this is a magical device that can provide both electricity and water just by providing it with hydrogen and oxygen, which were already aboard the spaceships. So they could use the same products that they needed for propelling the spacecraft were also providing the electrical power. I thought that was pretty magical. Al's article kind of goes into that a bit, plus talks about the basic operation of fuel cells, what makes them tick. They're kind of like batteries in a sense that they take chemical energy and make electrical energy out of it. But where a battery is storing electricity in a chemical form and perhaps being a one-way trip, for some batteries, fuel cells are different in they're actually consuming the fuel, which can be any of a number of things. It's not just hydrogen and oxygen like the space program uses. It could be anything from, I think his original example, like the first time it was tried was dilute acid, copper sulfate, and sheet metal and porcelain for the internals, which is similar to the phosphoric acid fuel cells of today. And that was back in the 1830s, so fuel cells have been around for a while. The fuel cells that went into space were charmingly named the bacon fuel cells. Do not use bacon or other pork products in any way. However, they were invented by Francis Thomas Bacon, capable of producing 5 kilowatts. I thought that was an astonishing number for such a device, but that's nothing compared to the fuel cells that went aboard the space shuttle, which were, 12, 16 kilowatts rated, something like that. So massive amounts of power that you can get out of these things, as long as you keep them fed with hydrogen and oxygen. Right now, space is where we use fuel cells perhaps the most. But do we have a potential for, in the future, using them, with transportation? Fuel cell cars, fuel cell trains, fuel cell ships, perhaps even, fuel cell airplanes at some point. I seem to remember a story recently of some sort of, startup, airplane startup working on fuel cell powered airplanes. That would be pretty cool, but I don't know what the future holds for that. Really good article, nice introduction to fuel cells, where we've been with them and where we could be going.
Well, that brings us to the end of this week's Hackaday podcast. Thanks very much for listening. This week's show notes with all the links is always at hackaday.com/podcast. And if you want to let us know about a hack, shoot us a line, tips@hackaday.com. And until next week,
keep on hacking.
Supporting the right to repair, blah, blah, blah.
Define your terms, blah, blah, blah. I don't see it.
That's because I haven't uploaded it? How about the Lumaphone? Sorry, the Luminophone. Oh, damn it. There. And then that'll cover that. Cut that in. Remotely interesting stream gauges. No. Remotely interesting beat. Stream gauges.
Well, we mentioned piss twice.